Looking ahead to the future of our planet, it is impossible to predict with certainty what changes will occur over the next 250 million years. However, based on current scientific understanding and trends, we can make some educated guesses about what the top 10 changes to Earth might be in the next quarter billion years. The Earth's lithosphere, the rigid outer layer of the planet, is composed of several tectonic plates that fit together like a puzzle. These plates are in constant motion, driven by the heat and pressure generated by the planet's internal processes. This movement is known as plate tectonics, and it has been ongoing for billions of years. Plate tectonics is responsible for many of the Earth's most dramatic geological features, including mountain ranges, volcanoes, and ocean basins. When two plates collide, the result can be the formation of a new mountain range, such as the Himalayas. When one plate slides beneath another, it can cause volcanic activity and earthquakes, as seen along the Ring of Fire in the Pacific Ocean. Over the next 250 million years, plate tectonics is likely to continue to shape the Earth's geography and climate. The ongoing movement of the plates will cause the continents to continue to drift and shift, changing the configuration of the oceans and landmasses. This movement can cause significant changes in the Earth's climate, as the position of the continents can affect the circulation of ocean currents and the distribution of heat and moisture around the planet. Continued plate tectonic activity may also lead to the formation of new mountain ranges and the closure of existing ocean basins. This could have significant impacts on global climate patterns, as well as on local ecosystems and human populations. Over the next 250 million years, it is likely that the continents will continue to move and shift as part of ongoing plate tectonic activity. This process, known as further continental drift, will lead to changes in the Earth's geography and climate. One potential outcome of further continental drift is the continued breakup of the supercontinent known as Pangaea. Pangaea began to break apart around 200 million years ago, and the continents have been slowly moving apart ever since. Over the next 250 million years, this process is likely to continue, with the continents drifting further apart and potentially reassembling into new configurations. As the continents continue to move, they may also collide and merge together, forming new supercontinents. Some scientists have predicted that a new supercontinent, known as Amasia, could form around 200 million years in the future. Amasia would be centered around the Arctic Ocean and would be made up of the continents that currently border the Pacific Ocean, including North and South America, Asia, and Australia. One trend that is likely to continue in the future is the rise of global sea levels. This is due to a combination of factors, including the melting of ice sheets in Antarctica and Greenland, thermal expansion of seawater due to rising temperatures, and the sinking of land due to natural processes. It is possible that sea levels could rise by several meters over the next 250 million years, leading to significant changes in coastal geography and ecosystems. Continued warming of the planet's climate is another major trend that is likely to continue in the coming centuries and millennia. This could have a range of impacts on the planet's ecosystems, including changes in precipitation patterns, shifts in the ranges of plant and animal species, and more frequent and severe weather events. Over the next 250 million years, the Earth will continue to be shaped by the forces of evolution, as living organisms adapt to changing environmental conditions and compete for resources. The evolution of life on Earth has been a continuous process that has spanned billions of years, leading to an incredible diversity of species and ecosystems. One potential outcome of continued evolution over the next 250 million years is the emergence of new species and the extinction of others. As the Earth's climate changes and habitats shift, some species may become better adapted to their environments, while others may struggle to survive. This can lead to the evolution of new traits and adaptations, as well as the loss of genetic diversity. Another potential outcome of evolution over the next 250 million years is the development of new symbiotic relationships between species. Symbiosis is a process where two or more species interact in a way that is beneficial to both. Examples of symbiotic relationships include mutualism, where both species benefit from the interaction, and commensalism, where one species benefits and the other is neither helped nor harmed. Over the next 250 million years, we may also see the emergence of new forms of life, such as intelligent extraterrestrial species or artificial intelligence. While the possibility of extraterrestrial life remains purely speculative at this point, the rapid advances in artificial intelligence and robotics suggest that we may be on the cusp of a new era of technological evolution. Although the rate of extinction has increased due to human activities, mass extinction events have occurred periodically throughout Earth's history due to natural causes such as asteroid impacts, volcanic eruptions, and climate change. It is possible that another mass extinction event could occur in the next 250 million years, with significant impacts on the planet's ecosystems and biodiversity. In addition to plate tectonics, other geological events such as volcanic eruptions and earthquakes are likely to continue in the future. These events can have significant impacts on local ecosystems and human populations, and could potentially trigger larger-scale changes such as climate cooling or mass extinction. Asteroid impacts have played a significant role in shaping the Earth's history, and they will continue to have an impact over the next 250 million years. These impacts occur when asteroids, which are large chunks of rock and metal that orbit the Sun, collide with the Earth's surface. The resulting impact can have catastrophic consequences, including mass extinctions, crater formation, and changes to the Earth's climate. One of the most well-known asteroid impacts in Earth's history occurred 65 million years ago when a massive asteroid hit the Earth near what is now the Yucatan Peninsula in Mexico. This impact caused the extinction of the dinosaurs and many other species, as well as significant changes to the Earth's climate and ecosystems. Over the next 250 million years, asteroid impacts will continue to pose a threat to life on Earth. While most asteroids are small enough to burn up in the Earth's atmosphere, there are still many larger asteroids that could potentially cause significant damage. Scientists estimate that there are around 2,000 potentially hazardous asteroids that could pose a threat to Earth in the next 100 years. The impact of human activities on the planet is likely to continue in the coming centuries and millennia. This includes the release of greenhouse gases that contribute to climate change, habitat destruction, pollution, and overexploitation of natural resources. It is possible that humans could develop new technologies and social systems that allow for more sustainable and equitable use of the planet's resources, but this is far from certain. Finally, changes in the Sun's behavior could also have significant impacts on Earth over the next 250 million years. The Sun's output of energy varies over time, and fluctuations in solar radiation can have effects on the planet's climate and atmosphere. In the coming centuries and millennia, it is possible that the Sun could enter a period of increased activity, leading to warmer global temperatures and potentially more severe weather events. In conclusion, the next 250 million years are likely to bring significant changes to Earth's climate, geography, and ecosystems. While some of these changes may be gradual and predictable, others may be sudden and catastrophic. It is important for scientists, policymakers, and individuals to work together to understand these changes and to develop strategies for mitigating their impacts on our planet and its inhabitants. By taking action to address the root causes of climate change, to protect biodiversity and natural resources, and to promote sustainable development, we can help to ensure a brighter future for our planet and for generations to come.